Hello everyone, welcome to the explanation. In this video tutorial, this is my 11th video tutorial, and in this video tutorial I will be discussing about switching technique in computer network. So in this I will be discussing about various types of switching, that is circuit switching, packet switching, message switching, and their definitions, advantages, disadvantages, applications areas. And this is one of the most important question for any exam. Either you are an engineering student, or you are a BCA student, or IT students, or you are going to attempt for any civil services exam. Okay, so this is one of the most important topic, and the question generally that is asked from this topic is a long question. So this video tutorial is a complete discussion about switching techniques. So what does switching means? So switching is the process of forwarding a packet from one port to another port. Okay, so if you are going from source to destination, so there can be a number of ports, okay, in between. So when the packet is going from one port to another port, so that is called switching. Okay, so when data comes on a port, it is called ingress. When it is coming, so that port is called ingress, and when the data is leaving a port or goes out, so it is called egress. Fine. So a communication system may include a number of switches and nodes. Okay, so they may have a number of ports. So from one port to another port, that is called switching. So they are generally, we have three types of switching methods. Okay, so circuit switching, packet switching, and message switching. So I'll be discussing these one by one. So going to circuit switching. Okay, so circuit switching, in circuit switching what happens, there is a dedicated path. Okay, so I'll give you a real world example. For example, if you are going from one place to another place, so there may be more than two paths. Okay, so imagine there are three paths to travel from one point to another point, or one place to another place, but you will dedicate a path. For example, there is 1, 2, 3 numbering of paths, so you will dedicate a path. So you will fix a path, that's path number 2. So whatever happens, you will travel through path 2 only. You will never change your direction. Okay, you will never go through path 1 or path 3. So that is called a dedicated communication path. Okay, so in circuit switching there is a dedicated communication path. Okay, when two nodes are communicating, so a communication path is fixed. It is pre-established. Fine. So when two nodes communicate with each other over a dedicated communication path, it is called circuit switching. So there is a need of predefined route. Okay, I told you. So the route is predefined. So once it is established, so the data has to travel from that particular path only. They cannot take another path. As you know, in computer network there are multiple paths from which the data can travel. But in circuit switching, the path will be fixed, from which the data will travel, and no other data is permitted. Okay, so that data will pass through that particular path, and no other data can travel through that path till a particular data is using that path. Okay, so in circuit switching, to transfer data, a circuit must be established. Fine. So a circuit is established, it means a predefined path is established so that data transfer can take place. So this circuit that we have established, they can be permanent or temporary. Okay, so the best example of the circuit switching is telephone. Okay, so telephone works on the principle of circuit switching. So a complete end-to-end path must exist before the communication takes place. In case of circuit switching, when any user wants to send data, that may be voice or video, a request signal is sent to the receiver. Okay, so we send a request signal to receiver, and the receiver sends back acknowledgement. Okay, so when we send a signal to receiver, they will send back us acknowledgement, ensuring that they are available. Okay, they are available for that dedicated path. So after receiving the acknowledgement, what we will do, a dedicated path is established, and then the data is transferred. Okay, so receiver acknowledgement ensure that there is a dedicated path, and after that, on that particular path, the data is transferred. So circuit switching, it is used for voice transmission. Okay, so fixed data can be transferred at a time in circuit switching. So this is one of the important portion of circuit switching. So there are three phases in circuit switching. First is circuit establishment, second is data transfer, and third is circuit disconnect. Okay, so we can see here, this is the sender, this is the receiver, so it can either pass through this path, or through this path, or through this path. Okay, so you can see a packet is divided in 3 parts, red, green and blue. So you can see all this red, green and blue, all these packets are going through the same path. They cannot take this path or that path. Fine. So first phase is circuit establishment. Okay, so we have established this circuit. Okay, my data will always pass through this circuit only. Then the second is data transfer. So after that I have transferred my data. So third is circuit disconnect. So we'll disconnect the circuit so that any other data can pass through this circuit. So in the same way the other data will establish the circuit and they will pass their data. Okay, so this was the circuit switching. So going to advantage of circuit switching, what happens? So in circuit switching, the communication channel is dedicated. Okay, so it is a nice thing that we have dedicated a channel for our data. So it has a fixed bandwidth. Going to disadvantage, there are number of disadvantages for circuit switching. Okay, so once the path is dedicated, we cannot take any other path. Okay, the only delay occurs in the speed of data transmission. Because the path is dedicated, we cannot pass our data through other paths. It takes a long time to establish a connection. Okay, so as we see, there is a phase, so connection establishment. Okay, so for this it takes a long time, for example 10 seconds. Okay, so for that period of time the data is not transmitted, so that is a wastage of time. It is more expensive than other switching technique as a dedicated path is required. Okay, so it is more expensive as we need a dedicated path for it. It is inefficient to use because once the path is established, okay, and no data is transferred, then the capacity of the path is wasted. For example, I have fixed my path, I have booked my path and I am not transmitting any data. So what happens? The capacity of that path is wasted. So in this case the connection is dedicated and therefore no other data will pass. Okay, so I told you in diagram. So this data is transferring. So you can see here as one data is transferring from this, so no other data will transfer from this route. Okay, so this route is fixed for the particular data. Okay, so these are some of the disadvantages of circuit switching. Going to application part. Okay, so application means where it is used. So the best example of circuit switching network is it was used in early analog telephone network. Okay, so when a call is made from one telephone to another, switches within the telephone exchanges create a continuous wire circuit between the two telephones for as long as the call lasts. So this is the best example of circuit switching. Okay, so second type is message switching. So message switching, so due to some disadvantages in circuit switching, message switching was used. So message switching is a technique in which a whole message is transferred. Okay, so the message is transferred in the form of complete unit and it is passed through various nodes. Okay, so it is based on store and forward. So whole message is stored somewhere and then it is forwarded when the receiver's buffer is free or receiver's resources are enough to take that data. Fine. So in message switching there is no establishment of dedicated path as it was in circuit switching. Okay, so no dedicated path, no path is established between sender and receiver. Fine. So the destination address, so we have a message and in message what we do, we append destination address. Okay, so message switches are programmed in such a way that they can provide the most efficient routes. Okay, so they are passed from one switch to another switch. So that message with particular destination address, they are passed to one node and again they will pass that message to whole complete message without breaking them. They will pass to another node. So each and every node stores the entire message. Okay, so they will store the entire message and then they will forward to the next node. So message switching treats each message as an independent entity. Okay, so they are not divided, they are a complete message. So there are two distinct important characteristics of message switching. So they are store and forward. So as I told, if there are two nodes, so they work on the principle of store and forward. So the whole message is stored at one node and again they are forward to the next node when that particular node is ready to accept the message. So message delivery, this implies wrapping the entire information in a single message and transferring it from the source to destination. Okay, so entire message, they are not break down into parts and parts. The whole message is there in this message. A switch working on message switching first receives the whole message. So you can see here it receives the whole message and buffers it. Okay, so it will store it until there are resources available to transfer it to the next hop. Okay, so if the next hop is not having enough resources, okay, to accommodate this message, so it will wait. Okay, so the message is stored and the switch waits. Fine. So this is the disadvantage. The message has to be wait, okay, if the resources are not available. So this technique was considered as a substitute of circuit switching. Okay, so as in circuit switching, the whole path was blocked only for one data or for two entities, sender and receiver. So going to advantage of message switching. So as message switching is able to store the message for which the communication channel is not available, it helps in reducing the traffic. Okay, so one advantage is it will store the whole message if the channel is not available. So in message switching, the data channels are shared by the network devices. Okay, so what happens, the data channel are shared. Okay, so it's not like circuit switching, it was fixed for a particular device, so for a particular pair of device. So in this they can share the channel. Fine. So it makes the traffic management efficient by assigning priorities to the message. So here we can assign priorities also. So for example, if a particular message is more important than another message, so it will be sent first. So disadvantage of message switching is, okay, so message switching cannot be used for real time. Why? Because it is based on stored concept. So if a message is stored and till the buffer is till the another device is ready, so it can be used for real time. Okay, so there is a delay. In message switching, messages have to be stored, for which every intermediate device is a network requires a large storing capacity. Okay, so another disadvantage is, as whole message is stored, so each device, each node has to be sufficient memory or capacity. So one of the best example of message switching is telegraph. Okay, so store and forward method was implemented in telegraph message switching center. For example, in most electronic mail system. Okay, so one of the real world example of this is the mail system, electronic mail system. So the delivery process is based on message switching. Okay, so the whole message is sent at one time. Okay, while the network is in the fact either circuit switched or packet switched. So the network is either packet or circuit switched, but the mail delivery system, the process of delivering the mail, it is in the form of message switching. Going to third part, so it is packet switching. So it is one of the most important and it is one of the recent switching technique that we are using together. So what happened in packet switching? Okay, so in packet switching, the message is divided into a smaller part. Okay, so a particular message we can divide into more parts, smaller parts, and then they are sent individually. Fine. So we have a number of packets and they can go through any path. There is no fixed path. Okay, so the message is splits into smaller pieces known as packets, and packets are given a unique identification number. Okay, so how do we know that if you break a packet into three parts, 1, 2 and 3, so how do we know this is first part, this is second part, this comes after this? So there is identification number for each of them. Each packet contains some information in its header, and such as source address, destination address, sequence number. Okay, so source address means the from where the data has come, from where the packet has originated. Destination address means where the data wants to go, and the sequence number means the numbering. So it is packet number 1 is packet number 2. Fine. So packet will travel across the network taking the shortest path. Okay, so now unlike circuit switching in which the path was fixed, packet switching, they can travel along any path. So whichever is shortest path, they will travel through that path. All the packets are reassembled at the receiving end. Okay, so due to sequence number, we can collect all the packet at receiving end and we can reassemble it in a proper order. If any packet is missing or corrupted, then the message will be sent to resend the message. Okay, so while as we have sequence numbers, if any of the packet is missing, we'll know that this packet is not there. So we'll send a message to sender to resend the packet. If the correct order of packet is reached, then the acknowledgement will be sent. So if we'll get all our packets, like all our divided packets in a particular sequence number in a particular sequence, then we'll send the acknowledgement message to sender that we have received the packet. So you can see this is the diagram of circuit switching. So we have seen there are 3 packets, red, green and blue. So you can see the blue packet has traveled through this path, the red packet has traveled through this path, and the green packet travels through this path. So packet switching. So today every technology is based on packet switching. For example, the internet that we are using, so that is based on packet switching only. So the internet is implemented by the Internet Protocol Suite using a variety of link layer technologies. For example, Ethernet, frame relay are common. Okay, so newer mobile phone technologies are also using packet switching only. So there are two approaches to packet switching. Okay, so one is datagram switching and one is virtual circuit switching. So in datagram switching, it's very similar to packet switching. So here the packet is called datagram instead of packet, and is considered as an independent entity. So it is an independent entity means what? It can travel to any like path. So each packet contains the information about destination, and the switches uses this information to forward the packet to the correct destination. Fine. So it is a connectionless switching. So what is connectionless? There is no predefined path for it. Okay, so there is no fixed path. It can travel through any path. Going to virtual circuit switching. So virtual circuit switching, it is also known as connection oriented switching. Okay, so it can be said as combination of both circuit switching and packet switching, because like circuit switching, there is a predefined path, there is a connection oriented switching. Okay, so we establish a connection first and then we transfer the packet, and like packet switching, we have divided our packet into various smaller packets. Okay, so in case of virtual circuit switching, a pre-planned route is established before the messages are sent. Okay, so this is like circuit switching. A virtual circuit is a means of transmitting data over a packet switched network in such a way that it appears as though there is a dedicated physical link. Okay, so as the name says, virtual, so it means it appears like there is a dedicated path. Okay, so that is called virtual circuit switching. So we have a difference between datagram switching and virtual circuit switching. So there are, in datagram, node takes routing decision to forward the packet. Okay, in virtual circuit, node doesn't take any routing decision. It means node doesn't have any right to say, okay, you can take this routing, you can take this path. Okay, you can go through this path. Congestion cannot occur as all the packets travel in different direction. Okay, so all the packets are traveling from different paths. So there is no congestion. Congestion means if two packets collide with each other, there is a congestion. So congestion can occur when the node is busy and it does not allow other packets to pass through. Okay, it is more flexible as all the packets are treated as an independent entity, but it is not that flexible. Fine. So these are the two approaches of packet switching. Going to advantage of packet switching. So it is cost effective, it is reliable, it is efficient. And disadvantage of packet switching. Packet switching technique cannot be implemented to those applications that requires low delay and high quality services. Okay, the protocols used in packet switching techniques are very complex and requires high implementation cost. If the network is overloaded or corrupted, then it requires retransmission of lost packet. Fine. So these are some of the disadvantages. Fine. So I think we covered the definition of all three types, advantages of all three types, disadvantages, and application areas. Fine. So this is one of the important topics. So I hope you understood it. Okay, fine. So till then, stay safe and like and subscribe our channel and stay connected with us. Thank you very much.